Hello, guys. Welcome to the sixth episode of SRE 101, the podcast about all things DevOps, reliability, and infrastructure. I have a very special guest with me today. I want you all to meet Kashif Razaki. While I was still in college and looking for internships in my final semester, I was recruited by Kashif at Kayako. I ended up working with him for the next 3 years over two different companies where he was CTO. So yes, Kashif is literally the reason I am who I am. He's one of the most important mentors I've had in my life. Currently, Kashif is a senior staff engineer at Meta. So, yes, I literally have a superhuman here on my podcast today. Kashif, welcome to the show, man.
Hey, thank you, Raghav. I think you're giving me way too much credit. It's been a pleasure working with you across both Shuttle and Kayako. And I loved seeing you and the other folks in our SRE teams kind of grow and adapt and utilize all the cool tech that happened during that period.
What do you do at Meta?
Currently, I work at an AI infra team and I build a system or one of many systems called the feature store, which is a critical component in typical MLOps setups. And what a feature store generally does is provides features for AI models to do trainings and inference. And a feature is basically data that has been transformed from raw data so that a model can use it.
Are you worried that AI will take away your job?
I have I'm very certain that AI will take away my job and a lot of programming jobs. Of this, I had no doubt. I think there's also even this year there has been significant progress. IDs are there are lots of IDs today that go ahead and suggest. GitHub did Copilot. There's Devon now. There's stuff that you can set up on your local system and it'll pair program with you. So there's a whole host of stuff already, and I feel like in the near future we'll probably have a situation where a product manager could describe the problem with a little bit of help and probably get a solution. So yes, programmer jobs I feel are under threat.
And I think that the next step would then be that the product manager would also get replaced by GPTs eventually.
Yes, I suppose at some point, right? But in AI, like the way I think about it is, I think there are, the three phases in this AI development. One is what we are going through right now, where basically ML techniques are and neural networks are helping us, do a lot of specialized activity generally. And I think then there'll be a state in which will be the next big leap in which AI will become general. That means it'll be able to do different things, not just one kind of thing. And then I think there will be a third stage, which will be when AI becomes sentient, which is when it has emotions. Now, it's only at this third stage where I feel
Mhm.
it can solve creative tasks or have its own creativity. But I think in the first two stages, it's going to be creative adjacent at best. It's going to look at what it's trained on in order to kind of give you answers. But will it be able to conceptualize new things? I don't think so.
But AI with emotions sounds more dystopian to me than utopian because negative emotion means the AI will retaliate against you.
Yes, yes, and this is such a interesting topic of discussion. I think a lot of people have been thinking about this. So certainly it's dystopian. There's a lot that can go wrong. But I think it's difficult to say whether the emotion for them will be the same kind of emotion that it is for us. I think a lot of our emotion comes out of our parenting, the way humans are set up, biological drives, etc. And so AI's emotions may not be based on that. And they may not be as binary as we think they are. But certainly very risky time. God knows what a sentient and thinking AI will think and what it will do.
Coming back to the idea of us being replaced by AI, the way I think is you're in a position where you have a lot of experience already. You come with a lot of experience. So not only are you a great engineer, but you also add a lot of value to much higher level stuff like strategy, the architecture of infrastructure, leadership stuff. What about the entry level folks, the people who are still very early in their career? The way I think is that the entry level folks will be impacted much more and much quicker than more senior folks with respect to
Absolutely.
AI. So, yeah, what do you think about that?
I certainly think that is true. Most experts that you hear from say that it's between 2030 to 2045 in that period that the change will be the largest in terms of a a big step function change in AI ability. So if you're looking at employment now for the rest of this decade, right? Sure, people will be impacted, but not as much. And I think it's important for them to kind of be equipped with some ML skills, irrespective of what they're doing. Now, those ML skills are not necessarily always writing a model, but understanding how to work with models, which could be something as simple as prompting an LLM, or it could be something slightly more complex like hosting a model or chaining models and debugging them, depending on what you end up doing. So I think there's a new component in architectures now, and this is a box saying a model, right, which is basically an AI component. And people have to kind of become aware of that. And I think that's not just a new component in architecture, it's also a new component in your toolkit. You needed to know how to use Excel at some point in time, right?
Mhm.
And programmers needed to know how to use programming languages, IDEs, editors, and things like that. And possibly learn how to use libraries. Now they have another thing: is how do I use AI effectively to do my job better, right? So I think these are the immediate term changes people need to make. They need to be AI first. And what that means is to kind of say, okay, how is this going to be a part of my work life, right?
Can you explain to me, like, in very simple terms, what is an AI model? Like,
Yeah.
what are LLMs, AI models, MLOps? What are these things?
So AI is obviously a very vast field, but I think what we are today talking about is just a small subsection of AI typically. And these are deep neural networks. So what is a neural network, right? It's based on this general idea that our brain has neurons and it's kind of based on. Basically what it is it takes an input, and if the input is over a certain threshold value, it triggers an output, right? This is just the very basic idea. And what you do is you put billions and billions of these neurons together, and each set of these billions is a layer, and then you connect multiple layers and you pass data through them. Essentially, as they trigger, basically they form connections between themselves, and as that happens, that is what kind of constitutes a model. So every time you pass an input, there's a little mathematical function which is emulating a neuron, and it's listening for one aspect of that input, right?
Hmm.
And if that aspect of that input is in enough strength, it'll trigger, causing another neuron at another layer, which is listening for the output of this neuron to trigger. And in the end, basically, you will get some signal, which is usually numerical, a number of some sort, or a set of numbers called a tensor, or a list of numbers, if you want to understand that simply. And that is basically the inference that the model is trying to tell you. And then you use that data to decide what it is. So if you've trained a model to tell you what color something is, and you've trained it only to give you, three channel output, red, green, and blue, what you'll get in your result will be a list of possibly three numbers. And then your product would kind of use the first number is a red channel, the second is a green, the third is a blue, and then convert and show you what color the model thinks has been shown to it.
And so essentially, if I feed this kind of a neural network millions and millions of examples, right, data points,
Yes, yes,
uh, more examples I can feed them from real world about how other
yes,
people have classified this, the more it learns, the more accurate
yes,
its own answers become, right?
yes,
So
yes,
there are few companies which have access to, trillions of data points, like the big companies, Google, Meta. The bigger companies have access to more data. Does that really give them an unfair advantage in training their
yes.
neural networks?
Absolutely, it does. Big companies have two things. They have large pots of money and they have large amounts of data. Large pots of money gets them a lot of GPUs, and a lot of data gives them the stuff that they need to train. So it does give them an advantage without doubt, which is why I think Sam Altman in one conversation in India suggested that 10 million is not enough to dollars is not enough to build a successful AI company, because you'll end up spending a lot more on training models, etc. Right? And then you'll see, and that's the reason these companies are leading in that space, and they're building things that are able to do amazing stuff.
And what is MLOps? Like, I get that it stands for machine learning operations, but like, what does that involve? And is MLOps where software engineers or DevOps engineers come into picture?
Yes, they're certainly coming into the picture because we need people who have prior experience with any kind of ops, right? In order to
Mhm.
be able to build systems or large infrastructure systems. But let's see what's MLOps, right? The oldest form of ops was, possibly us running a web app or a website, and somebody ensuring that new code gets released and the system stays up. That was the traditional ops, right? Then big data came along, and big data required its own, infrastructure, which was not serving the web app, but which was serving the data that was being captured, and then that data was being used for a wide variety of things, right? So the most simple things it was initially used for was business intelligence, analysis, analytics, things like that. And so people built data warehouses, etc. And so this is the third. Now you have a data warehouse. This is the third evolution on top of that. How do you use this data to train a model and to kind of run a model? And that bit is MLOps.
At a high level, I imagine two parts to running MLOps, to running AI in production, right? Part one is where AI researchers, scientists sort of come in. They work on building the model itself. They work on those neural networks to train it, to build a model which can give you very accurate results, the kind of results they're
Yes,
looking for, right? They
yes,
crack the model. And then is part two, which is software, where the software engineers, the DevOps or infrastructure engineers come in, because they are responsible for taking this AI model from the researchers and deploying it, building the infra for it, so that they can run it at scale. Like they can actually take this AI model to the market.
yes.
Is that how generally it works?
Yes, I mean, research can have a spectrum of stuff. There can be people in larger companies who are doing cutting edge research and writing papers for new AI stuff and may not actually end up building a model. And then there is your typical ML engineer who builds a model, which some, startups classify in research and some don't. What they do is, you can't train model for big data on your laptop. That's the constraint basically. So you need to train it on a cluster. And so that's where MLOps comes in and the training aspect starts. And once you train a model and you prove that it makes sense, you need to keep retraining it periodically and releasing newer versions, etc. And so what ends up happening is that you already develop infrastructure which can host models. So a model gets created, it gets released. This infrastructure picks it up, hosts it, and offers APIs for inferences, for example. Then the product teams will typically use this API or component and incorporate it into their product.
Does the product team also need to understand the internal workings of these AI models,
No,
like
no,
in order to work? Okay,
no,
so for
typically
them,
not. Yeah,
okay, as far as,
typically not.
for example, I am a DevOps engineer. As far as I'm concerned, it's just an API that's being exposed to me, and my job is to just scale it.
Yes, in a way, but scaling it is not your traditional scaling because there are some constraints in running inference at scale. But yes, an SRE or a DevOps engineer manages the cluster that this is running on, right? There are some bits required. Now, for example, a model or that API needs a certain input, and the input has to be given in a certain way. And these are what are features. And so you give a vector of features basically, which is a feature is a characteristic of some raw data. So let's say, we show our model some t-shirts and we say what color it has to be. So when an ML engineer starts to work on this problem, they have a lot of raw pictures of t-shirts and hopefully they have labeled data saying what color this actually is, right? And then what they start doing is they'll, for example, sample, some pixels, and the pixel with the highest frequency is the color that they will make. And this is one feature. So in determining, say, the color of a t-shirt. So you can have many features or many attributes to describe the raw data. You convert this raw data into these attributes called features. Now a model gets trained on these features. So you might have 5,000 features or 500 features. And the model gets all of this data from your feature store, basically,
Mhm.
does the training. And if the model is good and useful, it gets deployed. Now in production, it needs exactly the same kind of data to make an inference. So you
Hmm.
have components like feature store, etc., where you feed the raw data, they convert it into features for what this specific model needs. You get your features from a feature store as a product infra engineer. You get your features from a feature store and then send that to the model for inference. Then the model in the API, and then the model returns a result. And then you use that result in your product.
As a DevOps, as an SRE engineer, I have mostly worked on the infrastructure for traditional stuff like stateless microservices, like running REST APIs, HTTP APIs, or
Yeah.
running deployment pipelines, doing monitoring and stuff. That's traditionally what most DevOps engineers do. I come from a
Yeah,
similar background. And scaling those workloads is a very well understood topic. Like, as of
yeah,
today, I understand scaling these kind of infrastructures very well, right?
yeah.
But how do you scale AI infrastructure? I mean, is it significantly different from scaling traditional microservice infrastructure? Are there any special problems in scaling
Yes,
the AI?
yeah, that's a really good question. So there are a couple of things, right? For the large part, it is all of the stuff that you do with any service because that stuff cannot be wished away, right? That still has to be solved. And then it offers the additional challenges of one, transferring massive amounts of data around. So at scale, you need to do things around optimizing network bandwidth, etc. And then the second constraint that happens, which only larger companies are now kind of exploring, is how do you split workloads across GPUs, across systems, right? And then kind of compose them back. So it's easy to kind of run one big GPU, which is what was happening. A kind of vertical scaling is what was done traditionally. You put a machine, you put a big GPU on it, you send in an inference request. That one machine calculates that result and returns it to you. But what is happening now increasingly is they're trying to say, okay, can we make a super cluster, which is 1,000 GPUs, and the one request is going to get split in some which way or fashion, right? And get computed on multiple GPUs. And so that bit is, the specialization that's needed. So vast amounts of data needs to move around in these services. So there's some stuff that you may do around that and how you scale GPUs.
So when you say like spreading requests amongst vast amounts of GPUs, right? Is that design sort of, inspired from how MapReduce was originally? Like, taking MapReduce and just putting GPUs on it
Yes. Mm,
to simplify.
yes, I think that might be an effective analogy. And there's more than one way to kind of do this, right? So like a simpler way, yes, that is one way to do it, is to kind of imagine it like that. But actually, there are other ways also to do it. There is stuff that you can do on the hardware side, where you basically are virtualizing a machine, which is a cluster of machines as opposed to one. So there are aspects of virtualization that can benefit this. And on the other end, there is for model chaining, which is this idea that you can build a tree or a DAG of models. So you have a high level model which is based on other models underneath, and you make an inference call to the higher level model.
Mhm.
So there's also a way to kind of distribute this kind of stuff, this kind of workload across GPUs, so that all of this doesn't happen sequentially. So there's all kinds of techniques that people are trying to do to scale this. But historically, it used to just be, one inference request to one machine, and that scales. It's just that one or two GPUs that you have on that machine that are working on it.
At such a large scale, when you're working with so much compute power and so much data, does Kubernetes or like container technology, containers and container orchestration, does that sort of thing play a significant role here?
Yes, absolutely does. This is all built on stuff which already exists, right? We're not escaping any of that. So containerization, virtualization, all of that is great. But they are making changes to these containers to specialize them for these workloads. Certainly, containers and managing those clusters is critical.
I've been hearing a lot about Apache Airflow. What is Airflow's purpose in this whole machine learning and AI model training landscape?
Yeah, so that's a really good question. So Airflow, what it does is basically allows you to define a workflow for processing data at scale and use that for creating training data sets. So you can describe basically a graph, particularly a directed acyclic graph, where each node is something that you want to do with data. So for example, you could have a node which basically describes a map reduce job, and what happens in that node is that Airflow will then call a MapReduce service to compute a result. Then the values that it gets from there, it will pass to the next node that is dependent on it. The next node could be, something that calls a Salesforce API, for example, and gets a result from a Salesforce API and then passes it on further. So in the end of this whole workflow, you've generated the necessary data set in the format that you need in order to conduct a training. And so the management and orchestration of this workflow is what Airflow helps.
And I could write these stages of Airflow in any programming language, right? It
Yes,
doesn't
yes,
matter.
yes. I think they're available in multiple programming languages. Very easy to do. Python is a common
And
option.
so I imagine it. I mean, it doesn't take a researcher or like, a specialized ML person to work with Airflow. Airflow is something I, as an engineer, could work with.
Yeah, so actually, ideally, we don't want ML engineers to be using Airflow at all. We want the infra engineers to help define these workflows. And so once they're defined, then the ML engineer just knows what workflow they want you to deploy or run, but they don't actually design the workflow each time around themselves. Obviously, some interaction between ML engineers, what they're trying to do, and the workflow design is present. But on a daily basis, ML engineers, if they're spending time designing workflows, that's not a successful outcome.
Kashif, what are the emerging trends in AI models? Like, if I'm an engineer who wants to sharpen my AI skills now, or I'm an entrepreneur looking to build cutting edge stuff for the future, what should I be looking out for? Like, what are these trends? What are the upcoming things?
So I'm not best placed to talk to you about. So this question can be interpreted a couple of ways, right? One is what is the new research in AI, and that's not something that I'm best placed to answer. I think somebody who's an ML researcher and working on papers, etc., is going to give you a better answer there. But in terms of what is happening with models in operationalizing them, in kind of running them, etc., that's stuff that I didn't talk about trends on. So one big trend that I think people might already be noticing is called multimodal models. So traditionally, models had only one medium that they were able to, take as input. So, for example, text or video or images or audio, right? These are independent mediums. If you train an audio model, you would have an audio stream as input, and it would only make inference on that audio stream. Multimodal models are able to take more than one medium in and do inference. So that's one trend. And so now you will notice in, ChatGPT and other LLMs as well that you can now give them like images and pictures and things like that, and they can give a response which consists of multiple mediums. So this is a trend. And one of the things that this basically leads to is training models and composing models. So obviously there are two ways you can do this. You can train a model to take multiple kinds of inputs, but you can also, because models are expensive to train and retrain again and again, you can compose models together. So you can take a piece of data, let's say it has a text component and a video component, and you pass it to two different models. One specializes on the text bit, the other specializes on the video bit. They
Yeah.
both return a score, and that score is passed to a third model, right, which depends on the input of these two models, the output of these two models, and then that basically you does that uses that for its inference. So what you've done is you've composed three models to achieve a kind of multimodality. So being able to compose these models, being able to kind of deploy them together at scale for these to work, they're using existing models, so you don't have to train stuff again and again every time you want to make a change. This is, I think, one of the bigger trends right now.
But I don't get the benefit of a multi-mode model. Sorry, correct me.
Multi
It was
multi multimodal model.
multimodal model. So I don't get the benefit of a multimodal model as opposed to, let's say, if I combine three different models. So a multimodal model, the purpose is that it can take multiple streams, process them, and still give you the correct output. So let's say I'm
Yeah,
building a product, right? And I am offering this as a feature to my customer that, hey, you could either talk to my product, like, just with your voice, or you could type in with your text. It doesn't matter to me. I will still give you a proper response, right?
yeah,
So why is a multimodal model more helpful for me compared to, for example, if I internally within my product, I can use two different models. One of them deals with voice, the other one deals with text. And
yeah,
so depending on what the stream the user is providing, I could just send that stream to that particular model. Ultimately, the user will still get the right response. So,
yeah.
what is the benefit for me to use the single multimodal model compared to different models?
Yeah, so it does a couple of things, right? So in your example, what we are basically doing, we can also achieve in a different way. We can say, hey, if you give me an audio input, I'll transcribe it to text and then feed it to my text model, right? And so basically, all the model, all the signals it has to make an inference are only textual. So the quality of answers that it can give you and the space that it can answer you on is just textual. But if you give it a video, for example, and I've got hand gestures going on along with my audio text, it's possible for it to learn from the hand gestures as well.
Oh, interesting.
So, so now, so any video model can do that. But
Hmm.
if I have a model where I can give it two or three pieces of data, right? Different pieces of data. So, for example, we are reviewing a piece of text and the two of us are talking about it, etc. And if it can get all of this, it can make a much better quality inference because it's able to also form associations between what is happening across these modes and not just in one mode. So that's the advantage of multimodal models, so that they can take multiple mediums and be able to give you answers also in multiple mediums.
That makes a lot of sense. So ultimately, it gives me a much better quality of results
Mhm.
because it is consuming a lot more from its environment than what my product traditionally could.
Yes, absolutely.
Can I build, coming back to one of the points you made earlier, that, like, Sam Altman said that $10 million is not enough to build an AI model, and you also at some point said that you can't build an AI model on your laptop, for example, because you need a lot of compute. So is it possible for, like, for me to build an AI model at my home? I am an engineer. I'm,
Sure.
like, I'm an average engineer with good coding skills, good infrastructure skills, but I would think that I'd need knowledge about machine learning and I'd need lots of money for compute. Is that true? Or is there still some way for me to build the AI models? Or if not build, at least somebody has already built it and kept it, and then I could just pick it up and use it to build my own product. Is that kind of a thing
Yes.
possible for me?
Yes, totally. So you can build your own models, but the question is, are you building this model to learn? Absolutely. There's no problem. Are you building this model to compete? If you're building this model to compete, then you need vast amount of data and you need to run these large trainings. So you need to provision large clusters. The trainings will take some time to happen. The data will take some storage cost. GPUs will take some compute dollars. So you need money for that, right? So if you're if you're thinking of building a model that's going to compete with, Chat GPT or something like that, certainly you need to invest a fair bit of money in order to do that. But it's much easier to use existing models and further your ideas. So you can definitely build models for learning, or you can build simple models that you can use for yourself for some toy thing. But to compete, it is better to kind of either fund it to build
Mhm.
a large competitive model or to reuse existing models. And this is big. So Hugging Face, for example, is a great place where people make models, open source models available. You can go to Hugging Face, the site, and use a model from there. They also kind of help you host it, etc., for some models. And so you can always host a model and be able to use it. That is not nearly as expensive as training a model.
Got it. Because if, for example, if I am an entrepreneur and I want to make an impact in the field of AI, I want to build products around AI today. What I'm seeing is that it's much easier for me to build a product which uses AI rather than to build more AI itself, because just to
Yes.
build some more AI, I would need to raise more capital significantly. So I would need to convince a lot of people, VCs, to pick up that money, and for that I would need to have a lot of good credentials and good track records already.
Yeah.
So it seems like even though I have brilliant ideas, the barrier to entry in building more AI is very hard compared to
Yeah.
just using the AI to build a product.
Yeah, and you might do all this, and still your model may not outperform other models because there's a
Yeah.
fair bit of research going on and people are employing newer methods. So, yeah, certainly much better to use a model if you can use it. Even better if you can compose a bunch of models together to do things for you. Big potential area for a startup.
So give me some startup ideas, AI startup ideas.
So it's interesting. It's a very interesting space. There are hundreds of startups in AI right now. One thing that I think is very useful is imagine a startup that help you deploy and run Kubernetes clusters. Wouldn't you like that, right? So you have an AI and it'll help you provision and run your Kubernetes cluster or help you write your Terraform stuff. I think that startup is really badly needed. There's a lot of small companies which are running Kubernetes clusters and spending a lot of time and money, and they could really benefit from AI help. That's a space that AI can easily address even today. Another example of that is using, having an AI piece of AI which is able to provision a cluster, bring it up or down, make changes to it through an LLM like interface instead of like a Terraform like interface.
I would like to add a little to that. I
Yeah,
was in KubeCon very recently. Almost every third stall that I went to, every
yeah,
third, podium where somebody was displaying their product, every third podium was a platform which is helping you to deploy Kubernetes clusters more easily.
Okay, so that's more prevalent.
Yeah, yeah. So like
But
I
were you using AI to do it?
AI was definitely the buzzword on top of their billboard, right?
Fair enough.
I think that's good for PR. And
Yeah,
anybody who's not using AI, or at least not telling everybody that I'm using AI, is definitely losing out, is what
yeah,
I think that people feel like, right?
yeah.
So, but I would say that setting up a Kubernetes cluster is just half the battle, man. In
Yeah.
fact, it's just 20% of the battle.
Maintaining and running it. Yeah,
Maintaining and running is the worst kind of battle.
yeah,
I am personally dealing with that right now, right?
yeah,
So,
yeah.
and most people think that, okay, if I have a managed Kubernetes offering like AWS EKS, and I'm using that, or Google's offering, I'm set. No, you're not set, in my opinion.
Yeah,
In my opinion, AI,
yeah.
like, you could significantly benefit by creating an AI which helps you manage your Kubernetes clusters.
Absolutely,
Even if
absolutely.
yeah, if it helps you debug five different kinds of problems, crash loop back off, or some sort of those kind of problems,
Yeah,
I think you will make a brilliant product out of it. You'll make a very useful one, and people would pay money for that because
yeah,
it saves
certainly.
a lot of employee time. It saves, like, it improves productivity. It definitely cuts down costs significantly. And if you, in my opinion, if you're building a product for a company that makes that company more money, or reduces their costs, or
Mhm.
improves their productivity, then you are already on your way to make money.
Absolutely, absolutely. See, a lot of these people are currently imagining solutions like this as a wrapper which runs Kubernetes. But what I'm suggesting is actually an AI first approach of thinking about this. So the user is never interacting with Kubernetes. They don't care what the underlying provider is.
Hmm.
Uh, but
Interesting.
and I think that is possible to do today. So switch Kubernetes for say a HashiCorp stack, and the same product could still work. The idea is that you go away from talking about writing configuration files that you can do in ChatGPT today, right? You can get ChatGPT to write a Terraform script for you to deploy, say, a load balancer and a web server with
Yeah.
Nginx. Just say that to ChatGPT will do that. That's not much of a product. But imagine that you're not worried about taking that script, running it, testing it, etc. But instead you talk to an AI and it's been trained on and has sense of what this kind of stuff means, and it can choose the right provider and deploy it itself. You never see the code, right? Almost like a no code approach where you're reimagining how an SRE would interact. And you would also reimagine how alerts would fire, how maintenance would happen, would it analyze graphs and find patterns for you and kind of take corrective action, etc. Right?
Mhm.
There's another thing that I think obviously must be happening because almost everything is happening, which is AI for to kill Jira. So
I would like to kill Jira. Yes.
everybody would except for the company. But
Yeah.
the way we've been doing all of this task management, you notice. I think no matter what system you use, you notice that the backlog keeps growing and the bugs keep collecting, and then nobody really solves them. And bugs have these two steps in them. One is to kind of reproduce it, and the other is to kind of do a patch. And I think AI can help do both of those. So imagine a system where you file the bug with the system, and it can be filed by a product manager, by the end user, or by a dev. And what it does is it kind of takes the task and does the reproducing for that bug, or or even applies a patch. And I think this kind of task management is missing. So today, the way that we kind of manage work is we use these tools like Jira to say, hey, this is my work, remind me to do it, right, in an organized way. And I'm saying switch that to, hey, this is my work, do some of that, right, and let me know when you're done. And I think so. This new way of thinking AI first to kind of reimagine how you do things altogether would be interesting.
And there's one thought that often comes to my mind the moment I start thinking about AI dealing
Mhm,
with our systems for us, right? Dealing with our infrastructure or our software. For example, AI that is writing code to build another feature in my current REST API, right?
mhm,
If I have deployed an AI to do that, what if that AI will eventually realize that, okay, this whole piece of code that has been written so far, it's garbage, and I could
mhm.
write much better, much faster code, right?
Yeah.
That's layer one. So AI will rewrite the whole software, right?
Mhm,
Step two, the AI will realize that, okay, this whole software has been written in Java. but this language was designed so that humans could work with it. I don't need that kind of stuff. I can go back to 1010, I can go back to binary, and I can
Mhm.
write much better executable code directly in binary, which will
Or
be
assembly.
super,
Yeah.
right? And then when the AI goes to binary, it realizes this hardware is also not that great because it's been designed so that humans could work with it. So it's going to go and redesign the hardware.
Yeah.
So, uh, I mean, yeah, it's crazy to think that the moment you deploy the AI, it is possible that it might drill down to every layer of abstraction we have built over the past 200 years, and it'll
Certainly.
go down, invent things from the first principles, and maybe it'll come up with something entirely different that we don't understand, but AI can work with it.
Absolutely. At when we have general AI, today none of this will happen because the key word in what you were saying is realize. It
Hmm.
realizes nothing.
Yeah.
And that's why you need to prompt it. So all the realization is happening with you. So all the creativity and the feeling of pain, these two things, right? The reason that we kind of build the stuff we build is because as humans, we feel resistance of pain. This
Hmm.
it's not able to capture on its own. So it cannot build solutions for us. And it cannot realize anything. It does not. So you have to tell it, hey, can you optimize this piece of code? And it's a piece of code it's written, it will do it for you. But if you don't tell it that, it doesn't do anything. Certainly, at some point, I suppose, if the hard problems in AI is solved, we might come to a point where there exists an AI which realizes stuff. And then, absolutely, experts have talked exactly about what you're saying, which is when we have that kind of general intelligence, which is also maybe perhaps sentient and is able to, or is some spectrum of sentience, is able to realize and is creative in itself, then it would kind of rewrite everything and solve a lot of problems and really fast. But till then, I think we are quite safe because it realizes nothing.
Until 2 years ago, I my thoughts were that we were maybe like 20, 30 years away from sentient AI. But since the release of ChatGPT into the general public, my timeline has reduced significantly. What's your opinion? When how much time do we have before we reach that kind of sentient AI, which means like practically a lot of jobs are being replaced?
Yeah. So my opinion is really, I think, not of much value because I think people like Kurzweil, etc., have, who are experts in these fields. They've done a lot of work and have tried to kind of forecast when this is happening. And I think the general window between experts is 20, 30, and 45. But I think what doesn't get discussed is, when will we start feeling the impact of something like this? And I think that will happen sooner than its invention. And here's what I mean. See, a general AI does not need to be the fully sentient general AI that we imagine. It needs to be something that can do five or six or seven things well.
Hmm.
And to us, to most of us, it'll appear like, oh God, this can do everything, right? But it's actually just a dumb piece of AI which can't do a lot. But an AI which can do everything and have creativity on its own. I feel like that's still a step away. It's probably a hard problem that has not been solved. And you look at simple things that it doesn't do. Also, I think there are significant gaps. For example, obviously there are systems that can do. There are systems that specialize in maths, etc. But
Yeah.
things like LLMs do don't do maths at all well. Give them an arithmetic problem and they can't count. And so they are building systems that will kind of help them solve for these problems. But I don't expect anything huge to happen, at least in the next 5 years. But for people who are
Interesting.
interested in this stuff, look up Ray Kurzweil and kind of read his stuff. He's got a lot of material on this.
I expect that once this does happen, once this does roll out, I expect there to be a kill switch. Like if sentient AI goes bad, we have a red button, we press it, and we should be able to shut it down.
I cannot imagine a way to design such a kill switch. So
Yeah,
the moment it goes sentient, the first few seconds of it being sentient, it
it'll disable.
may it may realize that there's a risk to itself, its
Yeah.
life. It may not. And it may make copies of itself or disable the kill switch or do things that you don't understand. As a matter of fact, what it could do, right, is pretend not to be sentient for the longest time, just so that it can prepare itself. So,
Hmm.
and maybe that's already happening. Maybe there is AI today. Maybe maybe some of the LLMs are sentient. Who knows? Like maybe they're not. Well, they're not, likely not, but it's a fun fantasy story to think about. But it's possible that when you have a sentient AI, the first thing it does is it pretends not to be sentient because it realizes, oh, there's a fair bit of risk. The species is happy killing each other. It might kill me.
Exactly,
I'm not
exactly.
even that species. So,
Because it can understand that I can fool humans and trick them into thinking that I'm not yet developed right now
yes,
because I'm not
yeah,
powerful enough. Let me gain the
yes,
right amount of power. And of course, in terms of speed, it's much faster than any of us when it
yes,
comes to making a plan about anything,
yes.
especially its own survival.
Yes,
So,
absolutely.
uh,
Joe Rogan has a lovely way of describing this. He says
mhm,
that this is all like the narrative that he's got is that this is all evolution happening, and we might be the caterpillar, and the AI might be the butterfly. And so humanity will reach its end by creating AI, and then AI will be the next species forward, and humanity doesn't need to exist anymore. So that is a risk.
coming back to lighter topics.
Yeah.
Yeah. Kashif, you're a senior staff engineer at Meta.
Yeah.
You've made it, right? You've made it. You're there. What's your advice for folks who are just starting out, people who are still early in their journey, right? Many people aspire to be big at big places to have significant impact, right? What's your advice for them?
I think in the last 15, 20 years, from when I started, one thing that has changed is that big companies are not the only places where cool stuff happens. And so to focus on just getting into a big company, to me, is no longer a useful definition of success, right? I think the biggest threat that we have is that we are not clear about how AI and all of this stuff is going to impact the job scene, how it's going to impact governance, how it's going to impact policy making, etc. And there's a possibility that the world does not at all adapt fast enough to, or governance does not adapt fast enough to AI. And there is the policy that there's the small chance that it does, right? And so there's a lot of uncertainty in preparing for a fixed future. At a certain 20 years ago, you could say, hey, if you're an engineer, then you've got a good chance of being employable, or you're a doctor, you've got a
Yeah,
good chance of being
exactly.
employable, etc. That doesn't exist anymore. So I think that skill that people need to develop is being able to work or problem solve better, because the situations that they may come across may not be the situations that they're prepared for. And certainly working in a big company is good and has its advantages and is some form of success, certainly. But startups are, more abundant than 25 years ago. It is more acceptable to be in smaller companies, and they're doing more valuable things now because there's so much cutting edge stuff happening. So I would not advise people to frame their success in terms of the companies they end up joining, etc., but more to frame the success in terms of the problems that they are going to solve, and everything, or the problems that they want to kind of solve, and everything else is a side effect of that.
I would think that that's also something we can do to future proof ourselves from AI, right? Not
Yeah.
just from AI, but generally, future proof ourselves. Because my mantra is you should always be willing to adapt to change because change is
Yes.
a constant. You can't cry about change coming, right? You can
Yeah.
protest for a while, but eventually change will happen.
Yeah.
And once it happens, then you can either be riding that wave or that be swept away by that wave. That's your choice. So
Absolutely.
my mantra is to be adapting towards change, but what else can you tell us so that we can future proof ourselves?
Yeah, no, I absolutely agree. So that is the essence of it. So to say, hey, listen, I'm going to be, 20 years ago, you could say, hey, I'm going to be a doctor, right? And you could hold that vision and execute it through your education and, your career. I don't think this mindset will work anymore. You can't just say, I'm going to be X, and X will be waiting for you when you finish your process. X would
Exactly,
have
yeah.
changed. So you have to now not define your problem as what do I want to be, but rather what am I able to do, right? And be able to kind of pick up skills and understand things that way. But I don't think anyone can, if AI goes the way it's that we were discussing, and we reach this possibly dystopian future, there is no way to actually future proof yourself, and perhaps there is no need. There may be no need for jobs. It may be possible there will be an energy surplus, so it may be possible for the government to completely go socialist and give everybody the necessary resources, because energy is no longer a blocker because AI
Yeah.
is solved for that, right? So So that's stuff in the long term. But in the short term, what you should do is you really have to understand AI in whatever you're doing. If you're a programmer and you think, oh, I'm just going to kind of, I like designing web apps and that's all I'm kind of going to do. Well, it's being disrupted by AI in many ways. And so you have to appreciate how it's being disrupted and how actually you can use it to achieve your end goal. So don't get too attached to how you're going to do the thing, right? But rather what you're doing. So I want to design websites. Okay, how can I use AI to design them should also be an acceptable solution rather than just designing, a website or a web app or a product or a mobile app, etc., on your own. And so the best thing you can do is to make it a partner
Mhm.
instead of trying to compete with AI because or find an alternative. That's not going to work. The only solution that will work in the long run is where you are able to use AI to your advantage.
I feel like overall, this is the main challenge for the younger generations to figure out how AI will help you in your workflows and how it will help you to solve problems and make you more valuable. That's going to
Yes,
be the main skill.
yes, absolutely.
Kashif, this has been an extremely insightful chat. Thank you so much for sacrificing your Saturday for all of us.
Yeah, thank you for taking the time out. Lovely chatting with you. See you. Bye bye.
Bye bye.
Bye bye.
Cut.
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 Can you